Hello guys. So, yeah. So ignore that. But there's just one side. Let's deviate over here. This is the x and this is the y. Now, what we want is y to not be negative. Okay. And we would like x is positive. What we need is like y least negative as possible. But if x is negative and y is negative, it's like okay. So we want y positive and x positive. So that would be quadrant 1. We would prefer this. What would come second? As I said, y is always favored. So we don't care about the x value being negative, but y is positive, right? Now x is negative, y is negative. It's like, it's okay. Both are negative, so I'll prefer that. Here, y is negative, x is positive. Now you wouldn't prefer this because you don't want y as negative. But when you do, you also want x as negative. So that's the fourth quadrant. They're just numbers of quadrants. Now let's come back here. So these are 2 points. It doesn't have to be these points exactly. I've just chosen them in random. Now we use the distance formula. Wait, this is the wrong one. 1 second. This is something else. Okay. So the distance formula equals under root of x. Wait. Distance formula equals under root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Looks big. You'll memorize it in a while. B equals under root of 3 and 6 is number 1, 4 and 5 is number 2. So x2 is 4. 4 minus, what's x1? 6. No, 3, my bad. 3 whole square plus y2 5 minus y1, which is here. Y1 is 6 whole square. See, you see here there's a square. Okay, this square makes sure that the here it can never be negative because any number square is positive. Now, if you had gotten a negative number somehow, if this square wasn't there somehow, so for some reason, this would not work. Because over here, just not because it needs that, but if it didn't have it, you'd get under root of a negative number, which literally is imaginary. So we ignore that part. That's exactly why we have the square. There's also something, it's derived from the Pythagoras theorem, or the Pythagorean theorem, however you want to say it. So this equals 4 minus 3, 1 whole square plus 5 minus 6 minus 1 the whole square, which is also minus 1 the whole square. 5 minus 6. Okay, so D equals under root of 2, right? Because minus 1 square is 1, 1 square is 1, 1 plus 1, 2, root 2. So the distance is root 2. That's that. So I know that was a really bad edit, but here. Okay, now we're talking about collinear. So what collinear means is that there's a line over here, A is here, B is here, C is here. What collinear is talking about is it's asking if these all 3 points are collinear, which means that all of them in straight line, and can they be in a straight line? Suppose A was here, let's take it as x, y, z. X was here, y was here, and z was here. So A, that's See, so no matter whichever line you made, these three would not go together. It would have to go like this or like this or like this, but it would not go together in one line. All 3 points would move. This means they're non-collinear. This means they're collinear because they're all in one line, and they can intersect each other with one line. And if the point is collinear, you take the gradient of A and B. Suppose the gradient of A and B, m of AB, equals 2. Therefore, the gradient of B and C, m of B and C, should and has to equal to 2. So since if these two have the same gradient, that gradient is the constant in a line. Here the gradient wouldn't be constant and increase, whatever. Here the gradient stays the same. It increases. Gradient stays the same, but this is increasing. Now that means if m of AB equals m of BC, this means they're all in one line, which means they're collinear. That's that. That is the full coordinate geometry explained by Harshita. Thank you.